All right, so now we're going to summarize all the factoring that we've done so far. We've talked about factoring with the greatest common factor. We have factored by grouping. We have factored a trinomial when the leading coefficient is 1. We have factored when the leading coefficient is not 1, where we split the middle. We have looked at the difference of squares, and then we've looked at factoring square trinomials. Okay, so now we're going to mix them all up. For the last couple of weeks, we've done this, and then this, and then this. But remember, when you get to a test, it's not all going to be perfectly laid out. So let's go through that if we can. All right, the first thing I would recommend you do is count the terms. If you see 2 terms, of course, you always look for the GCF. Notice on the notes everywhere, the first step is to find the GCF if it's there. Once that's done, then look for a difference of squares. If there are 3 terms, you have several options. First, take out the GCF if there is one. If there is a GCF, then look at the leftovers. See if you can factor that using product sum, or split the middle, or maybe it's a square. And if there are 4 terms, of course, you take out the greatest common factor, and then you want to factor by grouping. So this is just sort of a review of everything we've done so far, and then we'll really jump into these in the back. Okay, so remember what to do whenever you have a trinomial where the leading coefficient is 1? Well, the leading coefficient is 1, so I need to find 2 numbers that multiply to make 16, but at the same time, they add to make 10. What are those 2 numbers? Those 2 numbers are 8 and 2. So this factors to x plus 8 times x plus 2. And you know what's so weird? Remember, usually I go in and put the smaller number first. I just messed up there, but what do you do? Okay, look at number 2. I have 2 terms here. They're separated by subtraction, and they're both squares. So that means that we're going to look at the difference of squares. So this is x squared. This is 13 squared. So this factors to x plus 13. Oh, x minus 13. All right, so my final answer here. Oh, I'm sorry. X plus 13 times x minus 13. All right. Number 3, we have 2 terms. So let's look for a greatest common factor. What do we have? Well, what's the greatest common factor of 12 and 8? 6. What's the greatest common factor of a squared and a? A. What's the greatest? I can't have a greatest common factor of y because there's no factor of y here. So this appears to be the greatest common factor. Okay, what's 12a squared divided by 6a? 2a. Bring down my plus. What's 18a y squared divided by 6a? Let's go term by term. 18 divided by 3 is 6. A divided by a divides out. I'm left with y squared. All right, let's look at the next one. I have 6y squared. Oh, my bad. Now, I still have 2 terms here. Is this a difference of squares? Because it can be broken down further. No, that's as far as this one goes, so we know we're done. And guess what else I failed to mention on all of these? You always check by multiplying. Always check your answer. I think I put that on the notes. But I just want to make sure that I say it here as well. Okay, again, is this right, Robadeer? I don't know. Check it. All right, look at these 2. Look at this term. Number 4, 6y squared plus 13y plus 6. How many terms are there? There are 3. Okay, is there a greatest common factor? Well, I see a 6 in both of these, but this doesn't have a factor of 6, so there's no greatest common factor. Okay, can we use product sum? No, because this needs to be a 1. Can we split the middle? Yeah, we're probably going to have to. All right, so we're going to take 6y squared times 6y. We need 36y squared. So I need 2 numbers that multiply Let me do my little thing here. I need two numbers that multiply to 36y squared and at the same time add to 13y. Okay? Let's look at 1y times 36y. That adds to 37y. Nope. 2y times 18y. Oh, that adds to 20y. Nope. 3y times 6y. Goodness. 12y. My bad. This is 15y. 4y times 9y is 13y. Okay, that's the one that we want. So this breaks up to 6y squared plus 4y plus 9y plus 6. So when we put these two together, the greatest common factor is 2y. We're left with 3y plus 2. When we look at these two, their greatest common factor is 3. We're left with 2y plus 3y, goodness gracious, plus 2. Oh, so you notice that they both have a 3y plus 2 here. So I'm going to factor that out. When I do that, I'm left with 2y plus 3. Okay, Robodeer, you have totally messed up this problem. I know, and I'm sorry. So let's come over here and look at it with the box method. Maybe, just maybe, I can redeem myself here. All right, I'm going to fill in my 4 terms. I've got 6y squared plus 4y plus 9y plus 6. All right, what's the greatest common factor here? 3y. The greatest common factor in this column is 2. The greatest common factor in this column is 2y. Oh, this row, I apologize. The greatest common factor in this row is 3. So this factors to 2y plus 3 times 3y plus 2. Oh my goodness. All right, so there we are. Maybe I've redeemed myself. I don't know. All right, let's look at number 5. Do we see any common factors? Well, even, odd coefficient. So I can't divide a 2 out of everything. So there's no greatest common factor. Now let's count the terms. On this one, I count 1, 2, 3, 4 terms. So that means we're going to use grouping. So what's the greatest common factor of x cubed y and 2x squared? That would be x squared, young grasshopper. Okay. What's x cubed y divided by x squared? xy. What's 2x squared divided by x squared? That's a 2. All right. Now, let's look at these two. What's the greatest common factor here? The greatest common factor is 8. When I divide that out, I am left with xy plus 2. Look how lovely that is. Now I'm left with x squared plus 8. And then I bring over my xy plus 2. Okay, there it is. Do you want to see it in a box? Because you can. All right, so I'm going to take those 4 terms. I'm going to place each of those 4 terms in one of the squares. So we have x cubed y plus 2x squared plus 8xy plus 16. Okay, look at this column. The greatest common factor is, oh, I see an x and I see a y. The greatest common factor in this column is 2. The greatest common factor in this row, x squared. And the greatest common factor here is 8. Okay, so this factors to x squared plus 8 times xy plus 2. And oh my gosh, that's the same answer I got over there. So I know it's correct. All right, let's look at this last one. Okay, Is there a greatest common factor? 4, 20, and 25 have no greatest common factor. So we say that they're relatively prime. That's what you call it. Okay. So you can always do, so we can't do product sum. I can probably do split the middle. And remember, guys, I've been doing algebra forever. Probably longer than some of your parents have been alive. So I know this is a square. This is 2x squared. This is 5y squared. So when I go off to the side, I'm going to do 2 times 2x times 5y. I get 2 times 2 is 4. I get 20xy. Oh, look, that's the same term that's there. So I know this is 2x minus 5y squared. Now, could I do split the middle? Absolutely. Do you want to see it? You know what? We'll save that for another day because I'll show you one maybe on the back that'll help. Okay, so let's go through this. That was just the review, guys. Now let's talk about actually factoring completely. To factor completely means to make sure the expression is factored to its simplest form. No greatest common factor anywhere. No product sum anywhere, okay? So we're going to follow the same steps that we did on the first page. You always look for the greatest common factor first, after you've counted the terms. So let's look at number 1. How many terms are there? There are 2 terms. So it could be a difference of squares. Well, I don't see a difference of squares, but there's one thing that I do see here. I notice I have 3 and 27 as a common factor. They have a common factor of 3. So I'm going to divide out the 3, and I'm left with x squared minus 9. Okay, now what happens? Well, I have 2 terms. They're being subtracted, so it's a difference. X is being squared, 3 is being squared, so it's a difference of squares. So this is really x squared minus 3 squared. So this becomes 3 times x plus 3 times x minus 3. And there it is. All right, let's look at the next one, shall we? I have m squared plus, excuse me, I beg your pardon. I have m cubed plus 6m squared plus 9m. Now, in all 3 of those, I said m. So guess what? M is a common factor. When we divide that out, we're left with m squared plus 6m plus 9. Okay, so now you can play product sum, or you can play square of a binomial. And you know what? This one right away, I know that 3 times 3 is 9. I know that 3 plus 3 is 6. So this is m times m plus 3 times m plus 3. Because my product is 9, my sum is 6. So the 2 numbers are 3 and 3. Okay, Robodeer, that's great. But when I look at my answer choices, it shows m plus 3 squared. All right, let's see how we get that square in. So if we have m squared plus 6m plus 9, this is the square of m. 9 is the square of 3. Remember, in order to be the square of a binomial, you've got to take 2 times the first term times the last term. And 2 times 3 is 6, so we get 6m. Oh, look, there it is. So I know that this is m plus 3 squared. Now, if you don't do this way, and you look at this one, and you stop here, you're wrong. Because guess what? You've got to remember to bring the greatest common factor out. So while this is my work here, I'm going to go off to the side and say, hey, Robodeer, I know exactly what I'm doing. And this is what I get. There is your final answer. Okay, so be very careful with that one. All right, let's look at Number 3. Number 3 is interesting, okay? Now, we can do the same thing again. We can play product sum, we can play square. I think for this one, I just want to do product sum because I am lazy. I notice that there is a 1 in front of here, so that means I can do the same thing. Even though this is not x squared and x, this is a square, and this is just a whatever term, okay? Because think about it. This is really x squared squared, okay? So this is x squared squared minus 10x squared plus 9. Now, I'm showing you this one, but I'm going to tell you right now, you will get more details of this in Algebra 2. So this is just something to look forward to. All right. I need two numbers that have a product of 9 and a sum of negative 10. Well, guess what? In order to have a positive product, the numbers have to be the same sign. In order to have a negative sum, that means both of the numbers are negative. So the numbers will be negative 1 and negative 9. So see this here? This is what gets written in the parentheses. So we get x squared minus 1 times x squared minus 9. All right, I'm messing with you here, okay? This can actually be factored further. It's a difference of squares. See how there are two terms? Both of them are squared and they're being subtracted. Same thing here. So I'm actually going to write this. Now, x squared minus 1 is x plus 1 times x minus 1. And then x squared minus 9 is x plus 3 times x minus 3. And I think to make life easier, I'm just going to show you these two factor to that. And then these two factor to that. When I did this in the notes, I actually had room. So underneath that, I wrote x plus 1 times x minus 1. And underneath this, I wrote x plus 3 times x minus 3. But that's okay. We will, you'll see it in the notes. And now you sort of have an explanation to go with it. All right, first thing I need to do for number 4 is I was making the filled in notes because evidently I didn't go into this much detail last year. So I'm making the notes and I get to number 4 and oh my goodness, I could not figure it out for the life of me. And then I realized that's because this is supposed to be z squared. So that's the scribble that I made in your notes, okay? Now, that's going to make everything easier for me. Okay, do I have a greatest common factor? Well, they all have a leading coefficient of 1, so the greatest common factor of 1. That doesn't affect me here. Okay, I have 4 terms, 1, 2, 3, 4. So I am going to factor by grouping. So let's put these two together. What is the greatest common factor of x squared y squared and x squared z squared? The beauty of this one is I said x squared for both of them, so that's the greatest common factor. When I do that, I'm left with y squared plus z squared. Okay, what's the greatest common factor of negative y squared and negative z squared? Well, Robodeer, you said negative, so I'm actually going to put a 1 there. When I do that, negative y squared divided by negative 1 is positive y squared. Negative z squared divided by negative 1 is a positive z squared. And then look what happens. I've got y squared plus z squared in both of them, so I'm going to take that out. Y squared plus z squared. And then I'm left with x squared minus 1. And goodness, look at what's directly above it. Remember that x squared minus 1 broke down? It's going to happen here too. So we're going to get x plus 1 times x minus 1. And then we're left with y squared plus z squared. And guess what? I've got that broken down. How about this? There are 2 terms. Can I make a difference of squares? No. A difference of squares subtracts. This is being added. My goodness, this is one of my favorite multiple choice questions, is to put this in there and have people try to factor it out. But guess what? This is not factorable. x squared plus, oh, I beg your pardon, y squared plus z squared is not factorable. Okay? In Algebra 1, there is no such thing as a sum of squares. Okay? So don't try to do it. All right. Take a minute and look that over. Let's look at number 5. All right, number 5, 24m squared n minus 6mn minus 20n. Okay, Robadeer, I see right away that there is a common factor of n. And then I also notice that each of the coefficients is even. So that means I can divide out a 2. All right, so out of the coefficients, I divide out a 2. Out of the variables, I see they all have an n. So when I divide that out, I get 12m squared minus 3m minus 20. Okay. So I took care of the greatest common factor. When I have 3 terms, I look for product sum. I can't do product sum because there's a 12 here. So I'm going to look at split the middle. Let me go and tell you, spoiler alert, it's not a square because 12 is not a square, 20 is not a square. So the only other option we have is split the middle. Okay, so let's look at 12m squared minus 3m minus 20. I'm going to multiply these two numbers, and I get negative 240m squared. I'm going to find two numbers that multiply to negative 240m squared, and at the same time, they need to add to negative 3m. Okay? In order to get a negative product, these numbers need to be opposites. So one is positive, one is negative. We're adding to a negative number, so that means that the negative sign is going to be in front of the bigger number. All right, you ready? 240. Oh, I just totally messed that up. 240 is 1 times 240. That adds to negative 239m. Now, if you've already looked at the notes, you know this is going to take me a minute. 240 is 1 times 120. That adds to negative 118. This is also 3 times 80. This is 4 times 60. This is 5 times 48. Okay, does 6 go into this? Remember your divisibility rules from 5th grade? 2 divides into this because it's even. 3 divides into this because when you add the digits, you get a number divisible by 3. So if 2 and 3 are factors, that automatically means 6 is a factor. Remember, 5 divides into this because it ends in a 5 or a 0. 4 divides into it because the last 2 digits are divisible by 4. 40 can be divided by 4. Okay, so 6 times negative 40n is negative 34m. 1, 2, 3, 4, 5, 6, 7. Does 7 divide into this? Nope. But 8 does because 8 goes into 24. So 8 goes into 240 30 times. Does 9 go into this? Add the digits. 2 plus 4 is 6. Does 9 divide into 6? Nope. So 9 does not divide into 240. So after 9 is 10. 10 times 240 is 24. Okay, does 11? Nope. Does 12? Yup. When we add that, we get negative 8m. All right. Now, in order to add to negative 3, I'm getting there. Okay, so let's try 13. Does 13 go into that? No. Does 14 go into that? You know, I didn't even check 14 yesterday. Let's see. All right, I'm just going to put my little tiny baby here. So 240 divided by 13, that doesn't work. 240 divided by 14, nope. 240 divided by 15, yes, and it goes 16 times. Now, here's the cool part. This is 15m, so this is negative 16m. That adds to negative 1m. What would be the next number after 15? 16. But guess what? It's already here. So this is my list of pairwise factors of 240. Now, I'll also notice that I never got a sum of negative 3. We have no sum of negative 3, so not factorable. So the trinomial, I need to put that in there. You said, I know, I need to put in the proper terms. So the trinomial is not factorable. Guess what though? Don't write prime as your answer. This is factorable. Look at the big picture. This is factorable. It is 2n times 12m squared minus 3m plus 20. Remember how when we go through these, I tell you to either bring it down or break it down? This is as broken down as it will go. Okay, so that's my final answer. And then I go to number 6. I mean, just think about it for a minute, okay? This is prime, that's as far as they go. That's my final answer. Remember, anything you take out has to come along for the ride. Just remember that, okay? And the last one, I have 3y squared plus 21y minus 24. Is there a common factor? Yes. What is the common factor? It's 3. So when I divide that out, I'm left with y squared plus 7y minus 8. All right. I see a leading coefficient of 1. I need a product of negative 8 and a sum of 7. Okay. So they have to be opposite numbers. The bigger number has to be positive. What multiplies to, I feel like I need to do this one out. We need to multiply to negative 8. We need to add to 7 because the signs are, I'm not on my game today. Signs are throwing me off. These need to be opposites, and the bigger number has to be negative. So let's do positive 1, negative 8. Oh, come on, Robodeer. The bigger number, oi. Whoa, positive. Bigger number has to be 7, so that doesn't work. So let's try negative 1, positive 8. That's where we do get 7. Oi, I apologize, y'all. So this becomes 3. Don't forget you bring down the 3. This becomes 3 times y minus 1 times y plus 8. And this one I think I want to check. When we FOIL this, just because it's just not, yeah, okay. First is y squared. Outer is 8y. Inner is negative y. Last is negative 8. So this is y squared plus 7y minus 8. Okay, we're good. All right, I feel better. All right. There's my final answer. All right, so here's the video for this lesson. When I made those practice problems, yikes, some of them are ugly. So give me a couple of hours in between all the other things I'm doing, and I will get a worked out solutions page for you. And I've already posted the practice with the answers, but I feel like to give you a really thorough review, I'll go through each one of them one by one. So it's going to take me a little bit because I'm not going to skip any steps, and I'll write it to make sure that you can follow. All right, have a good one.